Good day all of you. Today's gate question is an ideal op-amp circuit with a sinusoidal input is shown in figure. The 3 dB frequency is the frequency at which the magnitude of the voltage gain decreases by 3 dB from the maximum value. Which of the options is or are correct? Okay, as the question is like which of the options is or are correct, the question is multiple select type. Okay, now let us see the solution. Yes. So what are the options given? First read the options. The circuit is a low pass filter. The circuit is a high pass filter. The 3 dB frequency is 1000 radian per second. The 3 dB frequency is 1000 by 3 radians per second. Means first you have to check whether the given circuit is a low pass filter or high pass filter, and then we can go for this 3 dB frequency. Okay. Let us check it out. Okay. Now, yes, as in the options, they mention low pass filter and high pass filter. So we know the low pass filter means it passes only low frequency signals and it attenuates all high frequency signals. And high pass filter means it passes high frequency signals and it attenuates all low frequency signals. Okay. Now for our circuit, let us check what will happen for low frequencies and what will happen for high frequencies. Let us start at, suppose at f is equal to 0. At f is equal to 0. Okay. Yes, as a circuit consists of only the reactive element capacitor, you have to check what will happen for the capacitor at frequency is equal to 0. Okay, that is enough actually to identify the circuit whether it is low pass filter or high pass filter. You have to check the working of your reactive element, that is the capacitance at high frequencies and low frequencies. At f is equal to 0, we know that yes, the reactance of the capacitor Xc is equal to 1 by omega c or 1 by 2 pi fc. Okay, what will happen at f is equal to 0? Xc becomes infinite. Okay, this is 1 by 0, so it becomes infinite. What will happen when the reactance is infinite? Your capacitor, see this is the capacitor, your capacitor acts as open circuit. Means your capacitor, yes, that is 1 microfarad capacitor, let it be C. 1 microfarad capacitor acts as open circuit. Okay. Yes, when it is open circuit, you are giving Vn here, you are giving input voltage here. It won't go, yes, into the circuit because it is open. Okay. We know through open there is no conduction. Okay, so the signal will stop here only. So, yes, now what about the output here? Your output is 0. So, when your capacitor is open circuit, the output is 0. V output is 0. Okay, means what is happening? Frequency 0 means low frequency. You have to consider for 0 frequency, or even for low frequencies also, your capacitor is having highest reactance. So that high reactance will stop or attenuates the input signal. So you are going to get 0 output. Okay, so now at f is equal to infinite. Because it is ideal op-amp, you can check for ideal cases only. Okay. Yes, what will happen to Xc? Xc becomes, depending on this formula, if you keep infinite in the denominator, it becomes 0. Okay, means the capacitor acts as short circuit. It acts as short circuit. So, okay, what will happen if it gets short circuit? If this is short circuit, then Vin the total Vin goes into the circuit and you're going to get output. Okay, so what is V out now? Now if you see the circuit, it is an inverting amplifier because the signal is given at inverting terminal. It is inverting amplifier, and we know the inverting amplifier output minus RF by R1 into Vin. Okay, what is the RF here? Is 2 kilo ohms, so it is minus 2 kilo ohms by, yes, R1 is 1 kilo ohm into Vin. Okay. So what is this? This is nothing but minus 2 Vin implies your V out by Vin is minus 2. Okay. Or your mod V out by Vin is equal to 2. What is the meaning of it? when the frequency is high or it is infinite, yes, you are going to get output, and that output voltage by input voltage is 2. Okay. So for the first point, we know that it is not able to pass the low frequency signals, and on the second point, it is sure that it can pass high frequency signals. So you can say the circuit works as, yes, it works as high pass filter. The circuit works as high pass filter. Okay. Even if I draw a simple frequency response graph, suppose frequency response graph, this is F and this is your gain G, V out by V in, like this. Yes, at when frequency is 0, yes, V output is 0, or I can say, yes, as you are taking gain here, so what is happening? V out by V in is 0 here. Okay, so it is 0. When frequency is 0, yes, V out by V in is 0. The gain is 0. And when frequency is high, or when you are increasing the frequency, so what will happen? Yes, this circuit will allow the signal, so you're going to get output. So the response is like this. You're going to get the response like this. Okay, means it is passing only high frequencies and it is attenuating the low frequencies, and it is called high pass filter. Okay, so now for a high pass filter, yes, for a high pass filter, the 3 dB frequency is the formula for 3 dB frequency. Actually, what is 3 dB frequency? It is the frequency at which the magnitude of the voltage gain decreases by 3 dB. Okay, means this is the voltage gain, and if you take this as gain in dB, after getting gain in dB, at 3 dB frequency, the gain in dB reduces by 3 dB. Okay, so now for a high pass filter, the 3 dB frequency is F 3 dB is equal to 1 by 2 pi RC. Okay, if you substitute the values, you're going to get yes, 1 by 2 pi. What is R here? R is 1K, so it is 1 into 10 cube into C is 1 microfarad, that is 1 into 10 power minus 6. Okay, so what are you going to get? You're going to get 1000 by 2 pi. Okay, means it is, yes, this is the frequency. Now in the options, you are saying it is in the options that are given the frequency in terms of radians per second. Okay, so it is 1000 by 2 pi means 1000 radians per second. Okay, as omega is equal to 2 pi f. Okay, so to get omega, just simply multiply this frequency with 2 pi, then 2 pi gets cancelled. You are going to get 1000 radians per second. So totally what are the options here? The first one is we came to know that this is a high pass filter, and another point is the 3 dB frequency is 1000 radians per second. So if you observe the options, yes, the options B and C are correct. Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.